What's up, everybody? This is Danny Mathematics here with another example to explore, guys. And today, guys, I want to go over example 1 and example 2 of how to solve equations with variables on both sides of the equal sign, okay? We're going to solve equations that have variables on both sides of the equal sign, okay? And basically, guys, all we're doing is we're solving for the variable. The variable is the unknown value, which is x in some cases. In some cases, you'll see another letter that represents the variable, right? But basically, guys, we're trying to find out what is the value of x that make this whole equation true, okay? What is the value of x? What x has to be in order to make these particular equations true, okay? And all we're gonna do, guys, is we're gonna solve for x, and we're gonna follow these particular steps, these 4 steps as we solve for x. And I'm gonna explain the 4 steps as we solve example 1 and example 2, okay? So example 1, guys, we have example 1, 5 plus 4x equals 3x plus 26. Once again, 5 plus 4x equals 3x plus 26. The first thing, guys, that we want to do is divide both sides, right? We're going to split both sides by drawing this line going through the equal sign, so I can clearly see that I have a left side of the equation and a right side of the equation, okay? And then we're going to follow that with step 1 is combine like terms, okay? Combine like terms, okay? Now, what we're gonna do is, guys, we're gonna see if we can combine like terms on each side, okay? I can only combine the numbers, guys, or the constants, and I can only combine the coefficients and the variables together, okay? The coefficients that are attached to a variable, I can only combine that with another coefficient that's attached to a variable, and I can only combine the single numbers with one another, okay? So first, we want to combine like terms on both sides, right? On both sides. And actually, let me add this to my notes. On both sides, okay? So we're going to start off with the left side, okay? I cannot combine 5 with 4x because 5 is just a number. 4x is a coefficient and a variable that are in operation with one another. So we cannot combine these. And then the same thing on the right side. If I was to cover the equation and only focus on the right side, I cannot combine 3x with the number 26. I cannot combine 3 times x with the number 26. So in this particular case, guys, there's no like term to combine, so we can skip step 1, okay? Or pass up step 1. Cool. Now step 2, guys, is it says we're gonna label each value and we're gonna label each side. And the 2 labels that I want to go over, guys, are these 2 labels, okay? This is how I teach my class in order for them to understand the steps and the strategy, okay? Now, here are the 2 labels, guys. The heart represents a relationship, okay? So whenever you see a heart, guys, that is the operation, or that represents the operation between a coefficient and a variable. Remember, a coefficient is its own value. The variable, which is the unknown value, is its own value, and if they are attached to one another, they're in operation with one another, which I call a relationship, okay? And then S means single. S means single. Those are the numbers or values that are not attached to a variable, okay? So S means singles, which are the numbers that are not attached to a variable or in operation with a variable, okay? So all we're gonna do is, guys, we're gonna label each value, and due to the labels that we give each value, we're gonna be able to label each side, okay? And basically, guys, what we wanna do is we wanna separate all the values that are in relationships with one another or in operations with one another. We wanna separate those from the values that are not in operation with X, okay? Or in a relationship with X. That's how I would like to say it, okay? So let's just go down the line, going from left to right. 5 is not in a relationship with X, or it's not in operation with X. It's just by itself. So I'm going to put an S under 5, meaning that it's a single number. Okay? I have 4x. 4 is its own value. X is its own value, even though it's unknown, right? And 4 and X attached together is saying 4 times X. So that means that there's a relationship or an operation between them, which is multiplication, right? It's actually saying 4 times x. So I'm gonna put a heart under them. Equals, on the other side, I have the coefficient of 3, multiplied with the variable of x, or the unknown value of x. Once again, 3 is in a relationship or an operation with x, so I'm going to put a heart underneath those two values. And then the last but not least, guys, 26 is not in operation with x, so it's a single number. It's a single number. It's a single number. All right, now, ladies and gentlemen, what we're going to do is, we already did part of step 2. Now we're going to do the second part, which is we're going to label each side. One side we're going to label as the relationship side. The opposite side we're going to label as the single side. In the side that we label as the relationship side, guys, it could be either side, but I always go with the higher number that's in operation with x, right? Which 4 is the higher number than 3, so I'm going to label this side as the relationship side. Once again, the other side could be the relationship side, but you're going to be dealing with negatives and stuff like that. So I always go with the higher coefficient that's attached to x, or to the variable. I'll label that as the relationship side. All right, and then the opposite side is going to be the single side, okay? So now, ladies and gentlemen, we have already combined like terms, right? We label each value and each side. Step 3 is to move the values on their correct side, okay? Which, let me add to this, guys, all we're doing is match the symbols. Match symbols. That's all you have to do, guys, is we're matching the symbols. So if the symbol underneath the value matches the symbol of that side, then that value stays. If the symbols do not match, then that value needs to move to the opposite side. Well, it will match that side, okay? The symbols will match. So let's just go down the road, guys. 5 is a single number and it's on the relationship side. These two symbols do not match. So I have to move 5 to the opposite side where it does match. So the opposite of 5 is minus 5. Okay? Minus 5. And I can only subtract 5 from a like term. I cannot subtract 5 from 3x. It has to be from 26. So it's going to be minus 5 there. And then 5 minus 5, or positive 5 and a negative 5, cancels out, right? Cool. All right, now I'm going to go down the row. I still have 4x. 4x is in a relationship. 4 and x are in a relationship. And they're on the relationship side, so they stay. They stay. All right, now 3 is in a relationship with x, but it's on the single side. It needs to move to the relationship side, right? Because the symbols match over here. So the opposite of saying a positive 3x is a negative 3x. A negative 3x. Okay, and then I'm going to subtract it from a like term on this side, which is 4x. Okay, so minus 3x. Okay, so I'm going to cross this out because that cancels out. Remember, over here cancels out. So all I'm doing, guys, is what remains. Okay, all I'm focusing on is what remains. So on this side, I have 4x minus 3x, which is just 1x, or x. 1x is just x. Okay, and then over here, guys, I have 26 minus 5, which is 21. Okay, and remember, guys, I'm just going to put the 1 in front just so you can see. All right, so 4x minus 3x is just x or 1x. Okay, 1x or x is the same value. Okay, but I'm putting the 1 there so we can just do step 4. And then step 4, guys, is when we're going to break up the coefficient away from the variable. And the only way we can do that is by dividing, right? We have to divide the coefficient away from x, which is the variable, because their relationship was based on multiplication. So their breakup is the opposite, which is based on division. So I'm trying to get x by itself. So I'm going to divide both sides by 1. All right. And once again, even though we already know the answer, I'm just showing this so we can see, guys, even though we're dividing by 1 and we know that x is going to equal 21 as what we knew, okay? But I just wanted to go through the steps on this one because on the next one, it's not going to have a coefficient of 1, okay? So once again, 21 divided by 1 is 21. So x equals 21, okay? Now, what we're going to do is, guys, we're going to check our work. We're going to check our work, okay? So we're going to check to see if the value of x makes this whole equation true, guys, all right? So this is a technique to see if this whole equation is true. And all we're going to do is plug in 21 as x. That's all we're doing, guys. You're just gonna plug in the value of 21 as x inside of this particular equation. So let me just rewrite the equation, and I'm gonna put 21 in the parentheses where x goes. So I have 5 plus, I got 4 times x, which in this case is gonna be 4 times 21 because x is 21, okay, equals 3 times x, or now we're gonna put 3 times 21 plus 26. Now, ladies and gentlemen, if both sides equal, then that lets us know that we have the correct value of x. If both sides equal, that's how we know that we have the correct value of x. So remember, guys, PEMDAS, order operations, we multiply first before we add. So let me do the left side first. So I have 4 times 21, which is 84. So now I have 5 plus 84, and 5 plus 84, guys, is 89. So that means, guys, that the right side has to equal the left side in order for everything to be correct. So we're going to do the same thing over here, guys. Remember, order operations, multiply first before we add. So we have 3 times 21, which is 63. Right? And then now we have 63 plus 26, which is 89. 89. And we know that 89 equals 89. So this particular value of x makes this whole equation true. This value of x makes this whole equation true, because if we plug in this value of x in as x, then both sides of the equation will equal 89. Okay? So what I'm actually going to do is, guys, I'm going to put example 2 in a whole nother video, because I know this video is probably longer than expected, guys. But once again, guys, this is how we solve equations where we are finding the value of the unknown variable, or the value of the variable, right? And then we're going to plug in that value of the variable to see if it makes this whole equation true. And that's what we did, guys. All right? So thank y'all so much, guys, for following along. Please look forward to example 2. Thank you.